Does the seafloor recover after we dispose dredged material in the ocean? This is one of the questions that U.S. Army Corps of Engineers scientists at the New England District's DAMOS program are working to answer. In our first video, we explained how dredging is important for maintaining navigable channels and harbors all over the country, and how that material is tested before the Army Corps permits it to be safely relocated to an offshore disposal site. Once the Corps determines that the material is suitable to be placed in the ocean, the DAMOS program tracks where that dredged material is deposited at specific disposal sites and assesses how the seafloor recovers afterwards. DAMOS uses a tiered monitoring approach to assess recovery and study the long-term effects of dredged material on the seafloor. Following this tiered approach, disposal site monitoring is structured to determine if the seafloor and animal communities are recovering as expected after dredged material disposal. DAMOS scientists use this data to evaluate effects, make predictions about recovery, and generate informed site management decisions that are soundly based on years of study. One important tool the DAMOS program uses to monitor these sites over time is the sediment profile imaging and plan view camera system, also called the SPY-PV system. The system includes 2 cameras in specialized deep-sea housings that capture paired photos which provide valuable insights into the health of the seafloor. The plan view camera first takes a picture of the seafloor from above to show us what the surface of the seafloor looks like. For instance, we can see a soft-bottom muddy area or a hard-bottom rocky reef. Plan view images also provide us with a glimpse of the area's aquatic community, including any vegetation, fish, crabs, or lobsters. Although the camera might not capture the animals themselves, scientists can still identify their presence by looking for the trails, tracks, and burrows they leave behind. The paired profile camera then works like an upside-down periscope. It penetrates the seafloor to capture a cross-sectional worm's eye view of what the upper layer of sediment looks like to animals that live just beneath the surface of the seafloor. Scientists analyze these photos to identify any visible dredged material in the presence of worms or animal burrows. To collect SPY-PV images, researchers lower the camera system from the back of a survey vessel until it reaches the seafloor, where the pictures are taken at precise locations throughout the disposal site. We also collect photographs in nearby reference areas so we can make comparisons with the conditions at the disposal site. The SPY-PV photo sampling technique allows scientists to efficiently gather information from multiple stations over a large study area, providing a better understanding of the overall health of an entire area and allowing for more frequent and effective monitoring without additional expenses. When marine scientists review the SPY-PV images, they carefully observe and record evidence of animal activity, signs of chemical changes in the sediment, and assess the condition of the physical environment at and just below the seafloor surface. The images help to paint a picture of which animals are living in the dredged material and allow scientists to monitor disposals and document the recovery of the seafloor in the years following dredged material placement. When dredged material is first placed at a disposal site, it attracts marine animals that live in or near the seafloor. As time progresses, scientists expect to see more and more signs of marine life in SPY-PV images as the habitat is recolonized. The gradual recolonization process is known as succession. Specific types of animals observed in these images determine the stage of succession that has been achieved. Let's take a profile image from a soft-bottom DAMOS site and illustrate some of the important observations that scientists can make from the photo. In addition to a nice clear shot of a worm, we can see several tubes, burrows, and feeding areas made by other worms. The color of the sediment changes from top to bottom, providing clues about the oxygen content of the sediment, which is another indicator of habitat health. As part of the DAMOS program's tiered monitoring approach, disposal sites are checked regularly to gauge seafloor recovery. Images captured by the SPY-PV system over time help us map the location of dredged material and understand how quickly the seafloor is returning to its natural state. If the SPY-PV analysis suggests delayed recovery at a site, then additional tiers of the monitoring program are triggered to further evaluate the area and determine if corrective management steps should be taken to ensure the health of the ecosystem. All this work brings us closer to understanding the conditions that lead to healthy seafloor habitats and how to minimize effects from dredged material disposal. To learn more about the program, please visit the DAMOS website or explore the rest of the DAMOS video series, where we discuss additional aspects of the tiered monitoring approach, the beneficial uses of dredged material, and management options for contaminated sediments.